Hey, hello and welcome to today's GFG problem video. Hope you're doing well. So let's say today's problem, maximum path sum from any node. Okay, so what the problem is saying is we'll be given a binary tree and we want to find the maximum path sum. The path may start and end at any node in the tree. Okay, so what the problem is saying is we'll be given a binary tree and we want to find out the maximum path sum. And what the problem is saying is the sum can start or the path can start from any node and end at any node. So in this example, which is that maximum path sum? The maximum path sum is this one. Okay. So you can see, right? So the path is starting from, what is the start? It is 20 and end is 20, 10, this particular 10. Okay. So it is going across the root node. Okay. And if you see what is the path sum? So it is 42, right? So 42 is the answer. Okay. So this is the ask. Okay. Now how can we solve this problem? So this problem, it is going to be on similar lines of height of a binary tree. Okay. And time to find out the diameter of a binary tree. Okay. So let's see how it will work. So let's say we have a root here, right? So we are going to go to the left. Okay, we are going to run a DFS traversal and mostly it is going to be post-order traversal. So let's see. So we'll go to the left here. We are going to go to the left. Again, we'll try to go to the left here, but there's no child. So we are going to return 0. So that's what we also do in the height of the binary, right? So we're going to return 0 here. Okay. Now we are trying to go to the left here, to the right. Again, there's no child. So we're going to go and return 0. Okay. So the left and right subtree of 20 is returning what? 0 and 0, right? For example, if what the pseudocode will be. So for example, we are going to write int l equal to, okay, int l equal to, let's say DFS, okay, and that will be node dot left, right? This will be the pseudocode, right? DFS node dot left, and for example, our result, this is a result list, okay. And similarly, we'll have int r equal to DFS node, I've had node dot write comma result, right? So this will be the pseudocode. Now we have got, for example, node is 2 here. No, sorry, node is 20 here. So this one, right? This particular node, right? And its left and right child are both returning 0, right? Because there's no left and right child. That is why they're returning 0. Now what we're going to do here, we are going to have an int temp. Okay. So what this will be math.max. Okay. What we want to do here is we want to have the maximum, what do we say? We want to have the maximum sum path from the left and right subtree. For example, so what it is going to be? So math.max, it is going to be again max out of L and R. Okay, L and R. Okay. Okay. So it is going to be max of ln r plus node dot data. Let me explain this. What I'm trying to do here is, okay, out of this one or node dot data. So what we're doing here is, what is max of ln r? So here it is 0 and 0, right? So it is going to be 0 only, max of ln r plus node dot data. Node is this one, right? Node is this one. So it is 20. Okay. So here this expression evaluates to 20. And what we are saying is max of 20 comma node dot data again here. This particular one, right? Node dot data, which is 20 again, right? Which is 20 again. Okay. So what we are doing here, for example, let me rewrite the expression. Here. Let me try to erase this. Okay. So let's understand this expression, right? In temp equal to max of what we're saying, max of again L and R, that is whatever is the maximum path sum out of the left and right subtree plus node dot data. Okay. Okay. For example, let me try to explain this. Or out of this node dot data. So what does this mean? So it can be the case that here node is 20. Okay. But L and R, they were negative nodes, -1, -2. They were negative nodes. Okay, negative nodes. So what is the maximum? For example, if this was the case, -1 and -2. So it would have written what? it would have written max of L and R. So -1 is bigger, so we'll get -1 plus node dot data plus node dot data, which is what, 20, comma, 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 this particular one, 20. So which is bigger one? Is 19 bigger, -1 plus 19, or 20 is bigger? So 20 is bigger, right? So that is why that is what this expression. Now, why we are doing this? Why we are doing this? So we want to, when we are returning to the parent node, right? When we are returning to the parent node, okay, we want to, for example, if there was -1 and -2 here, right? On the left and right side. Okay. So when we are returning to the parent node, we want to return the maximum path sum for this particular subtree. Whatever elements exist for this particular subtree, we want to return the maximum path sum, and that's what we are doing here. So for example, if 20 is bigger than these right and left and right subtrees, then let's return 20, because that is a maximum, right? That is a maximum path sum, because the path can start from any node and end at any node. Okay, and hence we're going to choose 20, and hence I think if you got the expression, this one, right? Okay, now we also want to calculate at each node. We also want to calculate and check whether we have found a maximum path sum or not, because as you know, the maximum path sum can start from any path node and end at any path node. Okay, so this is a temp. Now we are going to have int answer as well. Int answer equal to, what are we going to say? Int answer equal to max of L plus R plus node dot data, or temp. Okay. Now, what is L plus R plus node dot data? What we're doing here is, we want to, for example, this maximum path sum, for example, if here it was 20, here it was 2, here it was 3, right? And here it was 2. Okay, here it is 1. Now, this particular, from this node we got 2, from this node we got 3, right? Now, what is the maximum path sum for this particular subtree? It is what? It is this particular, right? 20 plus 2 plus 3, which is 25, right? Which is 25. And definitely so, right? So what is this? This is what it says. L plus R plus node dot data. Okay, L plus R, which is what, 20 plus 3 plus node dot data, which is 20. Okay. So we want to calculate what? The answer, right? At each node, we want to calculate the answer, right? That's what we are doing. That's what we are doing. So here we are calculating at each node, we are calculating this particular step, int answer equal to temp, right? So what it is, for example, in this case, since it is, we don't have anything, right? 0 and 0. So L and R is 0 plus node dot data, which is 20. Temp is also 20. So any, like, answer will contain 20 only. Answer will contain 20 only. Now the third step is, we are going to have this result as well. Int result. So we are going to have result, which will be the final resultant sum, right? So we are going to check what? Max of result, comma, answer. This answer, the one which you have just calculated, right? Max of result, comma, answer. Okay. And while returning to the parent node, we are going to return temp. Why temp? Because we want to return the maximum path sum till this particular node, right? The maximum path sum till this particular node. That's what we want to do, right? Okay. So we are going to solve. So this is the intuition behind solve the problem. I think you'll understand better when we explain the code, okay, or when we write the code. Okay. So let me do that. So first I'll show the Java code followed by C++. Okay. So what we're going to do, let's have one int result equal to new int 1 result of 0. We'll initialize with integer dot min value, because we want the maximum, right? But we'll initialize with min value. Okay. Now we're going to write, let's write maybe DFS node comma result. We are going to pass. Okay. Now this will be what? DFS node comma int result. Okay. Now what will be the base condition? The base condition definitely will be node equal to, if it is null, right? That means it does not have any left and right child. Then we are going to return 0. Okay. Then we are going to return 0. Now what we are going to do? DFS node dot left comma DFS node dot left comma result. Right? We'll collect this result in left path sum. This is left path sum, and right path sum will be int R equal to DFS node dot write comma result. Okay. Now what we're going to have in temp equal to math dot max. So whatever is a maximum out of LNR, right? LNR, right? Whatever is the maximum we want to return, right? We want to return the maximum plus whatever is the maximum from LNR plus we will assign node dot data, right? And also, so this is one expression. Second expression is what? Node dot data. So it may be the case, I've already explained this. I've already explained this, right? So it may be the case that there was 20 and there was -2 and -3, right? It returned -2 here, it returned -3 here. L is -2, R is -3. So whichever is which is greater, -2 -3 plus 20, it gives us 15. Or this particular node dot data, is it bigger? Node dot data. So that is why this expression, comma node dot data, right? So whatever is the maximum we want to return to its parent node. Okay, that is why. So let's write answer as well. Now we also want to check. We also want to check if mat.max, right? Is the path sum. So what will be the maximum path sum? So that this will be L plus R plus node dot data, right? Or the temp which we have calculated, which is maximum, So whichever is the maximum, we'll assign it to the answer. And again, we are going to compare, right? Result with the result. Is the result which is already stored in this variable, is it bigger than the answer, or answer is bigger? So we are going to write max result of 0, comma, answer, right? And while returning to the parent node, we are going to return temp. Okay, that is the maximum path sum we are going to return. Okay, the maximum path sum till that, right? Till that particular node, till the child node. Okay, till the child node. So I hope you are getting this. For example, again, what we're returning the temp? Again, for example, if it was 20, right? If it was 20 and there it is 2, right? And now this is a leaf node. It does not have anything. It does not have anything, right? It does not have anything. So we are returning what? To what is the maximum path sum till, so we are returning 20 here. Okay, we are returning 20. If it was, for example, if it was 3 and 4, then we would have written what? To the parent node, 20 plus the max out of these two. 20 plus max out of these two, which is 4. So we would have written 24, right? We would have written 24. Okay. Okay. So that's what it is. So we want to return the maximum path sum. Okay. So let's compile this. Yeah, finally going to return result, right? Return result. So I'll show the C++ code as well. Again, my bad. Result of 0. $42. Let's submit it. Okay, the test cases are being processed. Please subscribe to the channel, like the video. Okay, let's quickly see the C++ code as well. So here's the C++ code. So what we're doing here is we took result and initialized with int min. Then we called a maximum utils. Now we are taking the left path sum, the right path, right? The max right path sum. And then here we are calculating the temp, whichever is the maximum out of L and R, take that plus node dot data. Or is node dot data itself is bigger? So when can this be bigger? When, for example, L and R are negative numbers, right? Then in that case, adding to the negative number to node dot data will lesser, right? And in that case, let's pass the bigger one. And then we are trying to calculate the answer here. So what we are doing here is we are out of the temp or L plus R plus node dot data, which is bigger, right? So that can be the answer. And we are again comparing this answer with the answer which is already part of result. It may be the case that the result which holds the answer is bigger than this particular answer. And that is why we want to check the maximum. right? And finally, we are going to return to the parent node. We are going to, whatever is the parent node, we are going to return the temp, which is this particular formula, right? Which is this particular formula. So that is the code in the description section. Thanks for watching. I hope you have got the solution. Please subscribe to the channel, like the video. I wish you a very happy, healthy, wealthy, and a great day. Thank you so much.